My note sheet? Oh, okay. All right, so first off, what I want to go over is the name of certain polygons depending upon how many sides they have. Okay, so if a polygon has 3 sides, what's the name of that? A triangle. Okay, if it has 4 sides, it is a quadrilateral. A square is a specific kind of quadrilateral. So a square has all the sides equal, so it's a specific type. If it has 5 sides, that is a pentagon. Yes. If there's 6 sides, it is a hexagon.
8 is octagon. I don't know what's that.
If there are 7 sides, that is a heptagon. Can you be quiet, please? If there are 8 sides, that is an octagon.
Oh, good job.
I remember this. We did this last year.
If there are 9 sides, that's a nonagon. You guys, you need to stop talking, please. At this rate, you're not going to have any time to do your assignment. Well, if everybody keeps talking, it's going to take forever. If there are 10 sides, that is a decagon.
Nobody taught me this before.
So I'm listing them for you. If there are 12 sides, that is a dodecagon. Okay, so now if there are any number of sides, so we're just going to use the arbitrary number n. So if you had like 17 sides, okay, instead of making up a fun name for that, we're just going to call it an n-gon. So if n was 17, you just say 17-gon, which is fine. Okay? Yeah.
What about 11?
I don't remember what 11 is. They figured it out last year. They looked it up. I think it starts with an S. I don't remember. All right, so your diagonals are segments that connect the non-consecutive vertices of a polygon. Okay, non-consecutive meaning not next to. Okay, so these segments connect the vertices that are not next to each other. Okay, so we're going to draw in the diagonals for 1 and 2. Okay, so for 1, from this angle right here, or this vertex in the rectangle, I can draw in 1 diagonal.
How do you do that? Why is he so straight?
It's not. It didn't even hit the vertex. I can also draw in a diagonal from this vertex here to that opposite side. Okay, so those are the only 2 diagonals in number 1. Okay, so you have to look at each vertice. So if I look back at this vertice here, I can't connect this vertice to this vertice with a diagonal because they're consecutive. They're next to each other. Okay, same thing from this one to this one. Those are next to each other. You can't consider that a diagonal. Okay? So I want you guys to draw in the diagonals in number 2. Okay, it has more sides this time. But go from each vertice, draw in the diagonals from each of those vertices.
I don't know how to say it, but there you go.
Hendecagon.
Hendecagon. That's 11.
What's the 11th one? Please.
All right. So for number 2, if I start, you're quiet now, please. If I start at this vertice here, I can't go up to this one, but I can go across to this one, and I can go across to this one. Those are considered diagonals. From this vertice, I can't go to this one, but I can go to this top one here.
What the? It's gonna make a star.
I can also go to this vertice over here. Okay, then moving to this vertice right here. I already have a diagonal drawn into this side, but I'm missing this one. Okay?
Yay!
From this vertice, I already had both of my diagonals. Same thing from this one. I already have both of those diagonals. Okay, so you want to make sure you check all of those vertices to make sure all of your diagonals are drawn in. You guys are very obnoxious today. Yeah, and now the weekend's over and we're back in school, so let's pay attention. All right, for our next type of problem, we want to draw the diagonals just from point A. So not all of them, just the diagonals from point A. So if I look at number 3, my vertex A is right here. I can't draw one up to this one, but I can go across to this one here. And I can go across to that one there. And then the last one, I can't draw in there at all. So I have 2 diagonals from point A. In number 4, A is supposed to be right here. Okay, so this vertex right here. I only have 1 diagonal for number 4. And that goes across to that left bottom corner. So when you draw all of the diagonals from one vertex of an n-gon, that's what we just did. Okay, so drawing all the diagonals from one vertex of any sized polygon, that separates the polygon into n-2 triangles. So if I look back up at number 3 here, n is your number of sides. Okay, so n is your number of sides. So in number 3, I have 5 sides, right? How many triangles did I form when I drew my diagonals? 3. Okay, that's where this n-2 comes from. I had 5 sides. I subtract 2, I get 3 triangles. In number 4, I had 4 sides. So I had 4 minus 2. I made 2 triangles. Okay, that works with any sized polygon. Okay, so we can see how many triangles are formed when we draw in those diagonals. So that helps us find the sum of the measures of the interior angles within a polygon. Okay, so the sum of the measures of the interior angles of the polygon can be found by adding the measures of the interior angles of those n minus 2 triangles. Okay, what do all the angles in a triangle add to be? 180. Okay, so each of these triangles here, all 3 of those angles have to add to 180. All 3 of those angles have to add to 180. Okay, same thing with these 3 triangles. Have to add to 180, 180, and 180. Okay, so that leads us into this polygon interior angle sum theorem. So the sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180. Okay, so this is your formula for the sum of your interior angles. We get this n minus 2 by how many triangles are drawn in, and this 180 by the sum of the angles within a triangle. Okay? So we're going to use that to do our first example here. So a convex polygon has 13 sides. We want to find the sum of the measures of the interior angles. Okay, I'm picking out these keywords because soon you're going to get into finding the sum of the exterior angles, or one exterior angle, one interior angle. Okay, so you want to pick out those keywords. This one is sum and your interior angles. So it's all of your interiors together. Okay, we're going to use this formula here to find that. Now, n in this case would be 13 because that's your number of sides. So I'm going to plug in 13 for n. So I have 13 minus 2 times 180. Okay, 13 minus 2 is 11. So I'm going to take 11 times 180. That is 1,980 degrees. Okay, so all of the angles within that polygon would have to add to be 1,980 degrees. Okay, just like when we had our triangles, all of our angles had to add to 180. Well, now we can figure that out for any sized polygon, what their angles have to add to. Any questions so far? To find the angle sum, yes. So I want to look at example 2. So in example 2, we want to solve for x. Okay? If we're solving for x, I need to know what all of my angles have to add to be. Okay, so I'm going to use that interior angle sum. So my first step is to find the interior angle sum. So that means I need to know how many sides there are. Okay, I have 1, 2, 3, 4, 5 sides. So n will be equal to 5. To find that sum, I'm going to take 5 minus 2 times 180. So I have 3 times 180. Okay, and that is equal to 540 degrees. So if I were to add every single angle together within that polygon, it would be 540. So now, how can I set up an equation to solve for x? So I can add all 5 of those angles together. Okay, all 5 those angles together, and they have to equal 540 because that's the interior angle sum within this polygon. Okay, so now what I want to do is combine like terms. So all of my x's here, I'm going to add those together. I got 26x. Okay, then I want to add all of my constants together. So I have this 10, a 5, a minus 5, and a 10. So that's 20. And that's still equal to 540. Okay, now I'm just going to continue to solve for x. So I'm going to subtract 20 from both sides. So I have 26x is equal to 520. Divide both sides by 26. And x will equal 20. Okay, so for this type of problem, you're probably not going to remember your interior angle sum for a pentagon. Okay? You might, that's great, but if you don't, you can always use this formula here to find that angle sum and then add them all together to equal that sum that you found. Okay, so that's true for any sized polygon. If you had 4 sides, same thing. If you had 7 sides, same thing. Okay? Any questions on example 2? All right, then moving on here. Moving on, we have a regular polygon. This is a polygon with all sides that are congruent and all angles that are congruent. Okay, so in a regular polygon, quiet please. All of your sides have to be equal to each other. They have to be that same length. And all of your angles have to be the same degree. Okay, that's what makes it a regular polygon. So we have a formula to find one interior angle of a regular polygon. Okay, so that one interior angle would be equal to that n minus 2 times 180, but then it's also divided by n. So that top portion is your interior angle sum. Okay, so we have our interior angle sum here. Now since it's a regular polygon, and I know all of my angles have to be congruent, all you would have to do is divide it by how many angles there are, which is how many sides there are. Okay, so that they're all equal to each other. That's how we find that one interior angle of a regular polygon. Now it has to be a regular polygon. If it says convex polygon, all of those angles could be different measures. Okay, they don't all have to be the same. So, with number 3, I'm going to show you 2 different ways to do this problem. Okay, so put the first way over here. And the second way over here. Okay, so in number 3, the measure of an interior angle of a regular polygon is 120. And we want to find the number of sides. So with this, I know how to find one interior angle, but I don't know what n is. Okay, that's your number of sides. So I can take this formula here, n minus 2 times 180 over n. That formula has to give me one interior angle, which is 120. So I can set it equal to 120. Okay, so I have my one interior angle formula set equal to my one interior angle. N is your number of sides, so we're going to solve for n. So to get n out of the denominator here, I'm going to multiply both sides. That way over on the left side here, those cancel out. So I have n minus 2 times 180 is equal to 120 n. Okay, next what I want to do is distribute this 180 to both of those terms. So I get 180n minus 360 180n minus 360 is equal to 120n. I distributed that 180 to both of those numbers. Now I need all of my n's on one side of the equation. So I'm going to subtract 180n. So I still have negative 360 is equal to negative 60n. And I want n by itself because I want to solve for the number of sides. So we're going to divide both sides by negative 60. And n will equal 6. Okay, so there's 6 sides if your one interior is 120 degrees. Okay, so that's the first way. I'm going to go through the rest of my note sheet here, and then I'm going to show you the second way. Okay, so not the rest of it, but the next part. So there's a simple relationship among the exterior angles of a convex polygon. So just like we had an interior angle sum, we have an exterior angle sum. So the exterior angle measures of a convex polygon, one angle at each vertex, is 360 degrees. There's no formula. It's just always 360. Okay? So this is always true. Okay? It's always 360. It doesn't change. Your exterior angle sum is 360. No formula, just write 360. Okay? So if I look at example 4, we want to find the sum of the exterior angles of a convex 27-gon. Underline sum and underline exterior angles. What is that sum? 360. No formula. Don't have to plug anything in. If you see sum and exterior angles of any size polygon is 360 degrees. Okay? Does pay to underline those key words. Alright. So now that I know that the exterior sum is 360 degrees. In your polygon, okay, any size, your interior angle, say this is our interior angle, and your exterior, make a straight line. Okay? So if my interior and my exterior make a straight line, what do they add together to be? 180. Okay? So if I have one interior plus one exterior, that will equal 180 degrees. Okay, so one interior and one exterior equal 180. So if I'm given one interior, I can find the exterior, right? Okay? This is going to be our second way in this problem here. So if I have one interior angle is 120, I can take 180 minus 120 equals 60. Okay, so this is your one exterior. Now, if I know my exterior angles always have to add to be 360, I can take that sum of 360 and divide it by one of my exterior angles. Okay, so this is your total exterior or your exterior angle sum. And this is your one exterior. Okay, so if I take 360 divided by 60, I still end up with 6. Okay, I still end up with 6 because there are 6 exterior angles in this polygon because there are 6 sides and there are 6 interior angles. Okay, that's your relationship among all of these. Okay, so I find this way a little bit easier. It's a little less work. As long as you understand that one interior plus one exterior make a straight line, which is 180. Okay? Questions on that second way? All right, last problem. We want to find the measure of each exterior angle of a regular hexagon. Okay?
360.
The sum is 360. So, since we have a hexagon, that's 6 sides, right? To find one exterior, since it's saying each exterior, not the sum, we're going to take our exterior angle sum and divide it by our number of sides.
Huh?
All right, so finishing up example 5 here. So again, we're taking our sum. So our exterior sum, we can divide that by our number of sides. And that will give us one exterior, which is 60 degrees. Okay, since I know my sum, I know there has to be 6 exterior angles because there are 6 sides. So I'll divide those to get one exterior angle of 60 degrees. Okay, any questions on